some basic graphs on Tuesday where we got like circles or lines, right? But for the most part, we want to look at other types of shapes, and so a big another one that's very common with our polar graphs is a cardioid. Okay, it's called such because there's like cardi, meaning like heart, so it's heart shaped. Okay, so that's why it's called a cardioid. And it says find the points at which the cardioid given by r equals 1 plus cosine of theta has vertical or horizontal tangent lines. Use a graphing calculator to check your findings. Okay. So the first thing that we have to think about is right now I have a polar equation, which is r equals 1 plus cosine of theta. Yes? But remember that my like tangent lines are dependent upon dx d theta and dy d theta. And so I need an x equation with thetas in it and a y equation with thetas in it. Agreed? Right now I don't have that. So I have to manipulate this so that I have both of those. Are we all with me there? Okay. Now, for our x, what does x equal? Cool. So right now I have an r. What is it missing? Cosine. So are we all okay that I can multiply this by a cosine of theta? But if I do that to one side, I must also do it to the other side. So I get a cosine of theta plus cosine square root theta. Yes? Are we all okay with that? So now, what does my left side equal? X. And so this, you could also write this as x of theta, right, is my x equation with thetas in it. Yes, no, maybe. And that's going to be kind of the trick for most of these whenever we are looking for derivatives, is that I'm going to have to convert this original polar into an x part and a y part. Because now, can I take the derivative of that?
Yeah.
Yeah. So I have x prime of theta equals negative sine theta so I'm bringing down my 2 cosine theta. That'll now be to the first power, but this is also a chain rule, so I also have to multiply by the derivative, which is negative sine. So I'm going to flip that sign here in the middle. Alright, okay with that. Then our goal is to do what with that? I have a derivative. Yay! What does that do? Or what can I do with it now?
Find where it's 0.
Cool, and that's going to give me which one?
Vertical.
Vertical, right? Because remember it's dx, or sorry, dy dx. So my dx is on bottom. So if my bottom is 0, then that's going to give me vertical tangents. Yes? Alright, so we are setting equals 0. How do we solve that? You can. Can we factor anything else out?
Sine.
Yeah. And we're left with 1 plus 2 cosine theta? That's not maybe. So it's a trig equation. It's been a hot minute since we've seen this. So then remember, once I have it factored, I can set each of my factors equal to 0 separately. So I'm looking at negative sine of theta equals 0, which is just really where sine of theta equals 0, and where 1 plus 2 cosine of theta equals 0, or in other words, where cosine of theta is negative 1/2. Yes, no, maybe? We're then having to look at our what? Unit circle. To remind ourselves of where does sine equal 0? 0 and 5. And where does cosine of theta equal negative 1/2. So it's going to equal positive 1/2 at pi over 3. Okay. But I need negative, so for cosine I'm looking in the second and third. So what angles in my second and third have denominators of 3?
2 pi over 3 and 4 pi over 3.
Yeah. Do we all remember how our unit circle works? Or at least vaguely. It's coming back to us hopefully. Okay, and all of those are potentially where we could have vertical, yeah? But what do we have to be careful about? Is also 0, then it's inconclusive. Okay? So we're gonna hold off on saying that I have vertical tangents there until we solve our other one. Yes or maybe? Yes. So our other second one's gonna work very, very similarly. The only difference is instead of multiplying by cosine, I'm gonna multiply by sine. So I get sine of theta plus sine theta cosine theta. So now on the left hand side this is now y. And can I take the derivative of that?
Yeah.
Yeah. What are we going to have to do in order to take the derivative though? For this second part. Product rule. Okay. So what's the derivative of sine? What's the derivative of sine again?
Cosine.
Times our,
Close.
so we get cosine.
Squared.
Okay. And then I'm looking at keeping sine the same and multiplying by the derivative of cosine, which is negative sine. So I get a negative sine squared there. Yes, no, maybe. So then what's our goal with that?
So equal to 0.
Cool. Do I have any issues with that right now? Can I factor that? No, we can't. Because I have cosines and sines, right? And they don't have, none of them, not all three of them have something in common, agreed? Okay. But I have a cosine squared and a sine squared, yes? Do we have a formula that relates cosine squared and sine squareds together? Yeah, what is it? Correct. So, notice that I have a cosine and a cosine squared. So, what am I most likely going to convert everything to?
Cosine.
Cosines, right? If I already have a cosine, I need all of the things to be cosines. Yes, no, maybe. So, remember that our Pythagorean theorem says I have sine squared plus cosine squared is equal to 1, which means that if I wanted to solve for sine squared, that's going to equal 1 minus cosine squared. Yes, no, maybe. Yeah, okay with that. And this is a negative, so I could also just multiply everything by a negative. So this becomes negative 1 plus cosine squared of theta. Yeah, so you also could have just plugged in the 1 plus cosine squared of theta here and then distributed the negative 1. I just did it in that equation instead. So now how many cosine squareds do we have?
2.
2. So what type of function do we have here?
Quadratic.
Ooh, how do we solve quadratics? Especially a quadratic trinomial. We factor them, right? Because remember that it's still, that's basically 2a squared plus a minus 1, right? So it's still going to factor the same way as all of my quadratic trinomials have factored. Agreed? Yes, no, maybe so. Do we need to see the steps for how to factor a quadratic trinomial? Or are we okay? Okay. I'd rather not waste the space, but I can go over it if we need to. So remember, we should end up with 2 cosine theta minus 1 times cosine of theta plus 1. Yes, no, maybe. Alright, so here I'm going to get a cosine of theta equals a, what kind this time? Positive 1/2, okay, which means that my theta is going to be pi over 3, right? Because that's what we got last time, it was just negative, that's why we went to our second and third. So then we also need our fourth quadrant,
Yeah.
which, what's another way that I could write 5 pi over 3? Negative pi over 3. So notice that this could also be plus or minus pi over 3, because sometimes you'll see it written like that. Are we all okay with that? And then where does cosine of theta equal negative 1? Pi. So do we have any of that overlap? Pi. So pi is not either right now, or it's inconclusive. We cannot say it is for sure either one. So we're going to say that, remember that I'm just going to add 0 to this list. That way then these are my vertical, and these are my horizontal. Yes, no maybe. All I did was take this 0 and move it over there. That way I didn't have to like write that twice.
Is there a different way to find out whether pi is 1? Since it's inconclusive.
You would you could look at your graph, but what it means a lot of the time is that it is not differentiable at that spot.
Mm-hmm.
So like if I look at my graph, right, my angle, notice so this would be my angle of 0, my angle of pi. Okay, we'd have to do a little bit more plotting, but what I'm assuming is happening is that this is my angle at pi, and notice that I have a sharp turn there, and so it's not going to be differentiable there. Again, most of the time they're not going to ask you about it. You just have to remember to not include it.
Okay.
That's the big thing. Other questions? Ready to look at another one? Okay, there we go. Given the rose curve, which it's named that way because if I look at the bottom right, it has petals, and so we call them rose curves. Yes, no, maybe. Okay. So what's this one ask us to do? Cool. What do I need in order to be able to do that? Y's and x's. Do I have y's and x's right now? No. Okay. So if I wanted x, what would I have to do with my equation? Multiply by cosine. So I'm going to get a 4 sine of 3 theta times cosine of theta. Yes? Which means that my y of theta is going to be 4 sine of 3 theta times sine of theta. Be careful there because a lot of people want to be able to combine those and we can't because the one that's given is in terms of 3 theta. We need to multiply by just a single theta. Now the fun part. We have a formula, yeah? Why did our formula tell us? So it's my original function, yes, which is just what? Hmm? Mm-hmm. pull from? Yeah. That's no maybe. Times what? I left off with 3 theta on my first one. 170. Okay. Alright, divided by 20. Luckily we don't have to do anything with this time. What do we have next? Okay. Times? Okay. Plus? Times? Woo. Yippee. Like I said, it's not necessarily a long one, or it's not a hard one, it's just a long one, right? Just remembering all the little pieces that we have there. Yes, no, maybe so.
Why is the sign with 3 theta on the bottom negative?
Because there's just a negative on your equation.
Oh.
It's just given to us as negative. Like if you wanted me to prove it, there's a lot of work that goes into
That's
that,
fine.
but that's yeah. Alright, next up, what's part B asking us to do? Okay. So what are we gonna do with those? Uh-huh. Do we want to do that by hand? Not really, but what do we have next there? Ooh, that's nice, right? And what would probably be a good thing to do if I'm plugging in 3 different things? Yes. Because we're going to have to plug in 3 different things, and so we don't want to have to type that out every single time. Any guesses as to what the first one's going to be? Why? Notice on top, both of our things have a what? And sine of 0 is 0. And then on bottom, this will be 0, but cosine will not. It would be 1. And so I'm going to have 0 divided by 1. So I should just get 0. Why are we angry? Oh, okay. Man. So if anything, typing this out is probably going to be the hardest part, but that graph is fun. So there's that. That's why I said that's fun. Right, so I do indeed get 0. So that's nice. So I'm looking at dy dx evaluated at theta equals 0 equals 0. Yes, no, maybe so. For the second one, what do we need to make sure though? Yep, which I am. Default is radians, so we're okay there. So I'm looking at pi divided by 3. Yes, no, maybe. Does anyone know what that is? I shouldn't know if you had seen it in your calculator enough, right? Because we get lots of square roots of 3's when we're dealing with tangents, right? And notice that I have some sines over cosines here. So that's why we're going to end up with a tangent like. But again, if this is calculator active, you can put 1.372. Either one is fine. Just if you happen to know that. Now, do make sure you round to 3 decimals though, if you're gonna put the decimal approximation. Thoughts on what the last one might be then? Yeah, so if I'm in 2 pi over 3, right, now I'm in the second quadrant. Sine is still positive, but cosine's going to be negative. So it might make sense that instead I get a negative square root of 3.
And it's symmetrical there.
It is. Utility to find the locations of all the horizontal tangent lines, discuss the significance of these points. So, which one of those up top do I need?
One.
Okay. And we're looking for where that equals 0? That's just y of theta, right?
Oh,
The derivative of that equals 0. Agreed? So we either have y prime of theta, yes? But do I actually need to calculate it this time? Do I actually need to calculate it though? What was our f of x? Sorry, our y? 4 sine of, it's gonna make me do parentheses, 3x times sine of x, yes? Right? Yes, no, maybe? So do I actually need to calculate it? No, because it's not going to ask me what it is, right? If it's calculator active, okay? It's just asking me where that equals what? 0. So what do we think? So what are our options? Yeah. So we have our options are theta equals, we said 0, pi over 2, pi, then yes, we have random decimal, which was 0.659, as well as 2.483. Yes? No, maybe. So what is this going to look like on our graph? We would have what there? Horizontal tangent, yes? So it's going to be where we are like just curving off, right? On some of these petals-ish. Kind of hard to draw, but you with me there? Yeah.
Do we have to check for?
We we can. I don't think that there are any this time because of how it's set up, but we can. We would just need 2g of x equals, what's our sign? 4 sine of 3x. Ah. Yeah, there's a lot. Yeah, if you notice, they're not crossing at the same place along any of them, so we would be okay with both of them. Which is why a lot of the time, if it only asks for one or the other, there's not going to be any overlap. If it asks for both, then that's usually where there's going to be some